Alright, here's your Unit 7 test review. For numbers 1 and 2, we need to solve each proportion for x. Number 1, x over 6 equals 12 over 2x. First thing you do is you simply cross multiply. 2x equals 6 times 12, which is 72. Now, divide both sides by 2 to get x by itself. It's 2x squared. Okay, so x squared equals 36. Now, to get rid of the squared, you take the square root of both sides, so x equals 6. So there, we solved for x in the first one. Okay? Remember, all you gotta do is cross multiply. So cross multiply here, you get 2 times x plus 1 equals 5x. Distribute that through. 2x plus 2 equals 5x. Subtract 2x. Subtract 2x, so 2 equals 3x. Divide both sides by 3. X equals 2/3. And that's it for the first two. Alright? Now let's look at number 3. Number 3, we have two obtuse triangles here. One of them looks like this. We have 110 and we have 30. And the other one is a little smaller. We have 110 and this angle is 40. Alright, now, in order to see if these are similar or not, first thing we have to do is make sure the angles are the same. If the angles are the same, we know they're similar. Okay, but if you notice here, we're missing this angle in C, and we're missing this angle in this triangle. So as long as this angle is 40 and this angle is 30, we know they're the same. Okay, so 110 and 30 is 140. 180 minus 140 is 40. So now, since these two angles are the same, we know by default this is also a 30-degree angle. So these two triangles are similar. All right, the question says, is the pair of triangles similar? Well, the answer to that is yes. Write a similarity statement. Okay, so our similarity statement, triangle, remember, keep the angles in order. I'm going to go ABC here. Is similar to triangle. Well, since I started with the 30-degree angle, I got to start with the 30-degree angle over here. Then I went to the 110. Then I went to the 40. All right, so yes, triangle ABC is similar to triangle XYZ by angle similarity. That is the postulate or theorem that proves them congruent. All right. Let's look at number 4. Number 4, we have two isosceles triangles. All right. Now, remember, for similarity, all three angles have to be congruent. All right. All three angles have to be congruent. Now, when we look at these two triangles, if you notice, our two vertex angles are different. So, are these similar? No. Why? Corresponding angles are not congruent. All right, corresponding angles are not congruent, because if these two angles are congruent, that means we know this angle is congruent to this angle, but since our two vertex angles are not congruent, we automatically know that our base angles will not be congruent on the two triangles. So this one is no, because corresponding angles are not congruent, and corresponding angles have to be congruent. All right, let's move on. All right, number 5. So we have this, or at least my version of it. M, K, P, Q, and R. 4, 2, 3, 6. So now we need to figure out if these are congruent, all right? Well, we automatically know that these two angles are congruent because they're vertical angles, all right? So now, if you remember, there's a side angle side similarity, all right? And we have the beginning stages of that because we have two sides around a given angle that we know is congruent. So now we have to make sure are these two sides in the same ratio as these two sides? All right, so 2 over 3 Does that equal 4 over 6? Why, yes it does. So that means that our triangles are similar. So are they similar? Yes. Triangle PKM is similar to triangle P. Now I went the long side to get to the K, so I need to go to the long side and I get to R. And then of course the third side is Q. So these two triangles are similar by side, angle, side, similarity. Okay? Because remember, if you have a pair of sides that are similar, between those pair of sides is a congruent angle. That is your side, angle, side similarity. All right? Let's move on to number 6. Number 6, a 6-foot man. All right, remember I say always draw pictures. A 6-foot man casts a 4-foot long shadow. A building, I'm paraphrasing, casts a 20-foot long shadow. How tall is the building? So we need to find x. All right, so we need to know that the ratio of these sides are the same as the ratio of those. Then we can find x. So we know 6 over 4 will have to equal x over 20. Height over shadow length equals height over shadow length. All right, remember that. You've got to keep the same things in the same places in your fractions. So now cross multiply. 4x equals 6 times 20 is 120. Divide 4, divide 4. X equals 30. So our building is 30 feet tall. All right, our building is 30 feet tall. So all we did was set up our proportion and solved for x. All right. Number 7 says find the geometric mean. So we want the geometric mean of 10 and 18. Well, if you remember, your geometric mean is x equals the square root of a times b. Well, here's your a and here's your b. So x equals the square root of 10 times 18, which is 180. So 180 breaks down to 6 times the square root of 5. That is your simplest radical form of 180. So 6 times the square root of 5 is the geometric mean of 10 and 18. All right? Because remember, your formula for geometric mean is x equals the square root of a times b. There's a times b. A times b is 180. Square root of 180 is 6 times the square root of 5, leaving it in the simplest radical form. All right, let's go to number 8. We have 3 parallel horizontal lines, and we have 2 transversals cutting through them. Okay, we know all of these are parallel. My marker is dying. So I'm going to change colors. Okay, so this is x, this is z, this is m, this is y, this is w, and this is n. So this one's multiple choice. It says which proportion is true for the figure at the right. Look at letter A. It says xy. Well, xy, it's hard to read. Well, xy goes this way. All right, none of the proportions that we went over go along the horizontal or the parallel lines. So we know A does not work. All right, let's look at B. B is Zm, okay, Zm over xz, so that's this over this. So that means it'll need to equal this over this. Let's see if it does. They say W n over yw. So we have this over this equals this over this. So that's a possibility to be our answer. Let's go ahead and double check just to make sure we can throw the rest of them out. C starts with xy. We follow one of the parallel lines, so that doesn't work. And then if we look at D, D is x over m. So it's the whole distance over mn. Well, if you notice, mn follows one of the parallel lines, so that one's ruled out. So the answer here is B. Zm over xy equals wn over yw. All right, that was number Number 9 is also a parallel line problem. Okay. So you just got to set up your proportion. Here we have these two lines, like so. And we have 3 lines going vertical that are parallel. Alright, this is 30, this is 10, this is 36, and this is x. So to solve for x, all we have to say is 30 over 10 equals 36 over x. That's the way our proportions work when you have parallel lines, multiple parallel lines cut by a transversal. So we have 30 over 10 equals 36 over x. Make sure you keep them lined up. Since we put the 30 first, we need to put the 36 first in the second equation. You could almost use this parallel line to separate your ratios. 30 over 10, 36 over x. Now, it's the same process. You cross multiply. 30x equals 360. Divide by 30. You can chop that off. 36 divided by 3 is 12. So x is 12. Quick way to verify that. 10 times 3 is 30. 12 times 3 is 36. The scale factor between them is 3 to 1, which does work. All right, number 10. Number 10, we got to solve for x. We have a triangle, and we have it now. That is an angle bisector going through the middle of the triangle. All right. So here we go. Whoops, I don't know what I did there. All right, so here it's an angle bisector. We know that. 5, 3, 5 over 2, and x. Well, if you remember back from one of the videos, we know that x over 5 over 2 equals 3 over 5. Okay, remember these are proportional to these sides. Okay? Now I know we're not supposed to have a fraction in a ratio, but instead of trying to get rid of this now, let's go ahead and do the cross multiplication and we'll get rid of it later. Alright, so cross multiply 5x equals 3 times 5 halves. So 5x equals 3 times, so that's 15 halves. Because remember, this is 3 over 1, and when you multiply, you just multiply straight across. So 3 times 5 is 15, 1 times 2 is 2. Divide both sides by 5. Now remember, when you divide by, when you have a fraction divided by a fraction, because I can make 5 into a fraction of 5 over 1, what you can do is take this fraction, flip it out, take the reciprocal, and multiply it by the numerator. So the reciprocal of 5 over 1 is 1 over 5. Okay, so now we're done with this. Now we just have a multiplication problem. Well, we can still do some reducing. 15 and 5. 5 goes into 5 once, goes into 15 3 times. So now it's 3 over 2 times 1 over 1. So x is just 3 over 2. Alright? Because again, we just set up our proportion. X over 5 halves equals 3 over 5. Alright? And then we just solved down for x. This might be the trickiest part for you. But just remember, like I said, we had 5. We can make it into a fraction, 5 over 1. That's in our denominator. We can take the reciprocal of that, which is 1/5, multiply it by our numerator, and then that is equivalent to dividing, okay? So 15 over 2 times 1/5. The 5 and the 15 are reduced to a 1 and a 3. And you just multiply straight across to get 3 over 2. All right? So we're halfway done. Turn the page over. Let's go to number 11. Alright, so here we have a right triangle, well, at least as close to one as I can get. And then we have another right triangle here, 3, 9, and x. Alright? Now, at first glance, you might say, well, that's not enough information. I've got to solve for all these other sides before I can do this. The answer is, no, you don't. Alright? If you notice, we have the hypotenuse and the short side of this triangle. Hypotenuse is x, short side is 3. That's going to equal the hypotenuse and the short side of the big triangle. Hypotenuse is 9 plus 3, which is 12, over the short side, which is x. Alright, so to solve this problem, we did hypotenuse over short side equals hypotenuse over short side. Alright, now again, you just cross multiply. X squared equals 36. Take the square root of both sides to get rid of the squared. So x equals 6. Okay, so again, we just used the proportions we know that the right triangle makes when you draw an altitude like so. And all we did was just solve for the x. We did hypotenuse over short side of this triangle here, and we did hypotenuse over short side of the big triangle. All right. Moving on to number 12. Number 12 actually uses what's called the side splitter theorem. Yes, I never actually told you what it was called, but this is what it's called, but that's not important. All right, so we have 7 over 2 and 9 over x. Now, since these two lines are parallel, we can kind of just basically extend this out, and our proportions are already set up for us. 7 over 2 equals 9 over x. Cross multiply, 7x equals 18. Divide both sides by 7, so x equals 18 over 7. You can make that into a decimal if you want. It's 2 point something, but I'm going to leave it as the fraction. All right, so that's all you do there. When you have your parallel lines, just extend the middle line out, and your proportions already set up for you. Isn't that wonderful? All right. 13. We got to find x and y now. All right, so here we go. So we have 7x, 8, 7, 5, y. Again, we can just extend this out. And our first one is set up for us. 7 over x equals 8 over 7. 8x equals 49. Divide both sides by 8. So x equals 49 over 8. And again, I'm just going to leave it as a fraction. Now let's solve for y. I'm going to erase this so I have the room. Now, for this one, what I would do is use, all right, because we have two similar triangles here, okay? So the side of this triangle, so 8, over the base of the small triangle, which is 5, that's going to be in the same ratio as this entire side of the large triangle. 8 and 7 is 15, over the base of the large triangle, which is y. All right, so 8 over 5 equals, of course we know this whole side is 15, 8 over 5 equals 15 over y. Cross multiply, 8y equals 75. Divide both sides by 8, and y equals 75 over 8. And again, I'm just going to leave it like that as well. Okay? So you could change these to decimals if you wanted to, but I'm not going to. All right, but that's how you do that one. All right? The side of this triangle over the base of the small one, and then the side of the large triangle over the base of the big one. That's basically what we did here. Okay? Moving right along. Number 14, again, that line through the middle is an angle bisector. We need to find x and y. We know that the whole side length here is 6. This is 5, and this is 4. All right. So now, what we need to do is, first of all, we need to get one variable in this thing so we can solve this. Well, what would this be? If this is x, okay, in terms of x, y would equal, well, this is x. This is going to have to add to x to give us 6. So we can say that this is 6 minus x. All right, so instead of calling this y now, I'm going to call this 6 minus x. Because we know that this over this is going to equal this over this. All right, so we know that 6 minus x over x is going to equal 4 over 5. Do some cross multiplication. 4x equals 30 minus 5x. Add the 5x to both sides. So 9x equals 30. Divide both sides by 9. And x equals 30 over 9. Pull a 3 out, 10, 3. So x equals 10 thirds. All right. And of course, we know y equals 6 minus x. Well, x is 10 thirds. So 6 minus 10 thirds. All right. Now we need to put this over a common denominator. Our common denominator is 3. So this is 6 over 1. So we multiply the 1 by 3. We have to multiply the 6 by 3. 6 times 3 is 18. 18 thirds minus 10 thirds is 8 thirds. Alright, so there's your x and y, 10 thirds and 8 thirds. And if you add 10 thirds to 8 thirds, you get 18 thirds. 18 divided by 3 is, of course, 6, which gives us the length. Okay? So that's number 14. Number 15. Now, number 15 talks about area ratios. We didn't go over area ratios, okay? But we'll give you a quick lesson on them. We have two rectangles. All right, and we know they're similar because it says for each pair of similar figures, so we know they're similar. Find the ratio of the area of the first figure to the second figure. This is our first figure, this is our second figure. All right, we know that our perimeter ratio, or the ratio of our sides, okay, that's actually called a perimeter ratio. From the first to the second is 8 over 3. Okay? Now, to get to the area ratio that they're talking about in this problem, we're going to take the perimeter ratio, square it, and that equals the area ratio. Alright, so we're going to do 8 thirds squared. Well, remember, when you square a fraction, you square the top and the bottom individually. 8 squared is 64, 3 squared is 9, and that is our area ratio. 64 over 9. Okay, so the ratio of the first to the second, for number 15, the area ratio is 64 to 9, because it's simply the perimeter ratio squared. Alright? Number 16 asks the same. Alright, here's number 18. Number 18 says, Jason wants to walk the shortest distance from the parking lot to the beach. The parking lot is up here, PL. The beach is out here. Okay? And that's length x. Alright? So we need to find x. And at the same time, we want to find y and z as well. Okay, so I'm going to write those up here. X, y, and z. Now, the first one that's probably the easiest to solve for is going to be y. Okay, the easiest one is probably going to be y because we have the hypotenuse and the short side of this triangle. And then of the big triangle, the hypotenuse is 3 plus y and the short side is 6. So we can set up our proportion with only one variable. Alright, so it's going to be 6 over 3 equals, we did hypotenuse over short side, so equals y plus 3 over 6. Alright, let me erase the word beach. Okay, so now you just simply cross multiply. 36 equals 3y plus 9. Subtract 9, subtract 9. 27 equals 3y, divide by 3. So y equals 9. Okay? So now what I'm going to do, I'm going to erase y and write in 9. There we go. Now, the next easiest one to find is x. Because we know x is the geometric mean of 9 and 3. So, x equals the square root of 9 times 3. So x equals the square root of 27. And the square root of 27 is 3 times the square root of 3. Alright? Because 27 is simply 9 times 3, and the square root of 9 is 3, and you leave the square root of 3 underneath the radical. Alright? Now let's do letter z. To do z, I'm going to erase the work for x and y. Now, oh yeah, let me write that in here too. 3 square root of 3. Okay, so now z is the hypotenuse of this triangle, and then 9 is the long side. Okay, so we can set it up that way, or we can go with the big triangle and make this the long side over the short side, which that's the way I'm going to do it. So z over 6 because it's long side over short side, equals, and then let's go to the small one here, long side, 3 square root of 3, over short side, which is 3. Okay? So now, cross multiply, 3z equals 18 times the square root of 3. Divide by 3, divide by 3. Z equals, well, 3 goes into 18 6 times. So that is 6 times the square root of 3. And that is your final answer. X is 3 times the square root of 3. Y is 9. And Z is 6 times the square root of 3. Alright. Number 19. Number 19 says, find the length of the altitude, which is this line out here, to the hypotenuse of a right triangle who has sides 5, 12, and 13. Now, the 5 is the short side, 12 is the long side, 13 is the hypotenuse. Alright, so we're going to call this y. We need to find variable y. So, how I would start this out? I would start out calling this x, which means this side is going to be 13 minus x. Alright? Now we have to solve for y. Well, to solve for y, I'm going to do hypotenuse over short side. So 13 over 5 equals hypotenuse over short side. 5 over x. So 13x equals 25. Divide both sides by 13. So x equals 1.9. Alright, so now let's put in 1.9 right here. And then this 13 minus x becomes 11.1. Okay? Now, why did we have to do that? Well, because we got to find y, and we know that y is the geometric mean of these two numbers. So we had to have these two numbers before we could find y. So that's why we had to find x and then figure out what that was. Okay? So now y is simply the square root of 1.9 times 11.1. So y equals the square root of 21.09, which is 4.6. Okay? So the length of the altitude to the hypotenuse of a right triangle with these three side lengths is 4.6. Because remember, y is just the geometric mean of these two numbers. And to find these two numbers, we set up a proportion. We called this x. And we did hypotenuse over short side equals hypotenuse over short side. Solve for x, we got 1.9. We know this is 13 minus x, so 13 minus 1.9, 11.1. Geometric mean, multiply them together, take the square root, and that will give you y. Okay? Now, let's look at number 20. I know, again, we haven't gone over this material yet, but I'm just going to show it to you to kind of introduce you to it. We know that the sides of a rectangle are in the proportion of 2 to 3. Okay? Well, that's your side ratio, which can also be called your perimeter ratio. All right? And as in problem 15, to get your area ratio, you simply square your side or perimeter ratio. So squaring that would give us 4 over 9. Now it says the area of the smaller rectangle is 48 square feet. What's the area of the largest? Well, since our area ratio is 4 to 9, okay, so we have small over big, so put the small area on top, which is 48, and that equal, so 4 over 9 equals 48 over x. We did the small one over the big one both times. We're still going to have to cross multiply. So 4x equals 432. Divide both sides by 4. So x equals 108. That is the area of the larger rectangle. Area of the larger rectangle. Alright, because remember, your area ratio is simply your side ratio or your perimeter ratio squared. So all I did was take 2/3. I took 2/3 and I squared it. And remember, when you square a fraction, you have to square the top and the bottom individually. So that would be 4 over 9. Alright, so this is your Unit 7 review. Make sure you understand how to do these problems. And we'll be taking the test tomorrow. Good luck.